Let's talk limits here a little bit. So we've got two special limits. We know that if we ever have a limit that is indeterminate, we've got to do something. We've got to find a way of rewriting it so that it can be determined. So take a look at these two limits. These are special trig limits that you're going to have to learn. And both of them are indeterminate. If you hadn't noticed, as sine approaches 0, it becomes 0. And as x approaches 0, oh, well, that's a problem. Down here, as cosine approaches 0, that's 1, but 1 minus that over 0. Wow, those are both indeterminate. There are lots of forms of indeterminate statements, but 0 divided by 0 is the one that we see predominantly when we're first studying limits. We'll get to a lot more of this later in the year, and we'll use an amazing rule called the L'Hôpital's rule. It is outrageously French, but it's going to be a wonderful thing for limits. Right now, though, so look at these two. We can't factor them. We can't rationalize them. We can't expand them and subtract, and there's nothing that you can think of algebraically normally that we would do here. So what do we do? Well, what do you think we should do? This, my friends, is the graph of sine of x divided by x. And if we're trying to take the limit of it, in other words, if we're trying to find out what is the limit of this right as it is approaching 0, gosh, what do you think it would be? It's actually undefined right at that very specific point, but it turns out that we can see pretty closely what's approaching. This is 0, this is 2. So graphically, we can answer this first question. What is this first limit? So we're just going to say this has a limit of 1. We saw it on the graph. We could check it out. You could zoom in as far as you want. The point doesn't exist at 0 exactly, but the limit as I approach 0 is awfully close to 1. So we're going to use these two special limits as just facts. I'm going to give you these two facts. You're going to use them. This happens to be the graph for 1 minus cosine divided by x. And as we take the limit, as we see what happens as we approach 0, what do you think that function will be getting close to? I'll give you 3 guesses. I'll give you 3 guesses, but the answer is 0. So honestly, that's your 2 answers right there. Use it, love it, live it. If you wanted to do this numerically, you could do it that way also. So algebraically, it's very tough, but we're going to use these to get some algebraic limits. Bada bing, bada boom, we got some examples here. Let's work with these. Okay, so you'll notice if you plug in all 4 of these examples, please trust me that most of them are going to be indeterminate. So we start looking at these. I want you to say, which one of these does it resemble, the sine or the cosine type function? And hopefully you say, gosh, that looks a lot like the cosine function. We want to rewrite this so that we can clearly see this limit somewhere in there. And bingo, there it is. 1 minus cosine x over x, we've got it. It's just times 1/5. So now you can say, what is 1/5 times 0? 1/5 times 0, that seems pretty easy. The next one, also very similar, but notice this says 6x. Maybe you can't see it. Oh, that'd be a shame if you could. This says 3x. According to our limit here, they have to be the exact same angle. And these are not the exact same angle. Ladies and gentlemen, I would like to make those the exact same angle, but I cannot do anything to change the 6x inside of the sine function. So I'm going to change the other one. You see now, I still have 2 times sine. I can't change that, but now this says 6x down here. What would this limit be as we're approaching 0, sine of 6x over 6x? Once again, I'm going to stress, this angle and that angle down there must be exactly the same. It is 2 times 1. Okay, this next function looks exactly like this, just turned upside down. We have a corollary. If sine x over x is 1, then the reciprocal must be the reciprocal of 1, which is still 1. However, I want you to note that this is not indeterminate. It's not approaching 0. I can actually plug pi over 2 into the function. The last problem, I give you a hint.